Testing 1, 2, 3.
रात के 11-12 बजे कल बर्फबारी थी ना, जब पहुँचे ना उस दिन जैकेट थी टोरंटो थाना थी अच्छा वहाँ से करी ये स्मॉल में एक्स्ट्रा स्मॉल आता है, मेरा स्मॉल में बड़ी यही उठा रहे, मैंने सर्दी इतनी है एक साइज कुछ नहीं।
Okay, everyone, let's get started. Welcome. We're in our 4th week. We're almost halfway through the course. But before we begin, I found a pencil sharpener at the end of last class. I don't know whose this is. If it's any of yours, come pick it up. If not, I'm throwing it out. Anyone put their hand up right now? No? It's not yours. I know you're lying. Okay. So, small announcement before we begin. Assignment 3 is due tomorrow, and for assignment 3, question 3 requires symbols, and I actually didn't get the symbols on Thursday. And generally how it works is I'm supposed to cover the module in the week that it's presented, and so I'm a little bit behind right now. And so question 3 you might not be able to tackle right now, but after this lecture you'll be able to do it. So yeah, that's just me just not keeping up with the schedule, but yeah, so question 3, if you tried it and you couldn't do it, don't worry about it, because we didn't cover all the material required to be able to solve the question. But we will today, so that's good. Okay. Any questions before we begin? Anything administrative? No. Kristen, no. Yeah, but any questions? Administrative, about the assignment, about midterm, about anything else? Any questions at all? Things are going well? Everyone's getting 90s? Yeah? Awesome. Perfect. That's what I like to hear. Okay. So, like I do with every class, let's just begin by going over, well, where we are in the course right now. So, should I, is this right enough? I don't think it is. I think I might need to close some of these. Is that helping or not? I don't even know. Does that help? Yeah? Okay. Okay, it's a little darker, but, oh, wait. It's a little darker, but I'm sure us math and computer science majors are used to working in very dark rooms for long periods of time, so not a big deal to us. Anyways, so module 1 was intro to computer science. We saw nums, nats, and ints. And in this module, we essentially just tried to turn mathematical expressions into Dr. Racket. So turn math into Racket. And we also saw tracing. Okay? That's module 1. Module 2, we saw the design recipe. Is that right? Is that your recipe? Okay. And we also saw the string data type. Now, notice a common pattern throughout all these modules is we keep introducing new data types. And that's all we're really going to be doing for the rest of the course. We're just going to keep showing you guys new data types. We started off with the most basic ones, nats, nums, and ints, because you guys saw these from high school in your math classes. We then went on to introduce strings, and we then went on to introduce booleans. And for the rest of the course, all we're going to be doing is introducing new data types. So it's important to understand what a data type is. It's just a type of a value a variable can take. And so in module 3, we saw the Boolean data type. And then we also saw conditionals. And now we're going to see the symbol data type. And then module 4, we're going to see the structure data type. And then module 5, we're going to see the list data type. And this is where we get introduced to recursion. And we're approaching it. We're pretty much at this point. At the end of this week, we're going to be roughly at this point. And starting next week, we're going to go into module 5. So starting next week is when this course gets hard. Up till now, it shouldn't be too bad. Module 4 is a little bit more challenging than the previous modules. But module 5 is when this course really picks up. So just make sure you guys are ready to learn a lot come next week. Okay. So with that being said, let's get into the lecture slides. So last class we stopped essentially at conditionals. We talked about what a conditional was. And we said that a conditional was our way to essentially tell our program to do multiple things at once. And the way a conditional looked was it had a con, and then there was a question, followed by an answer. And then there was another question, followed by another answer. And we kept doing this for all the possible things we wanted our function to do. And the important thing we needed to note was the question, it needed to return a Boolean. And the reason it needed to return a Boolean was because if it was true, we would go over to the answer. And if it was false, we would go to the next condition. And that was kind of the whole logic flow of how conditionals work. It was just question, answer, question, answer, question, answer, and the question had to return a true and false value. And that's because we needed to know whether we're going to go to the answer or whether we're going to go to the next question. Okay? Any questions about that? Okay. So the next thing we're going to talk about is something called nested conditionals. And this is a little bit more complicated than regular conditionals. The idea is that when you have a question, answer, one of your answers can be another conditional. So you can just have some question, and then in your answer, you can have another entire conditional. And then it can have a bunch of question, answer, and then one of those answers can be another big conditional. So you're just nesting conditionals within each other. And we're going to demonstrate that through an example. So a question we have here is, a museum offers admission, and it offers free admission for people who arrive after 5 p.m. And for people who arrive before 5 p.m., if you're age 10 and under, it charges you $5. But if you're over age 10, it charges you $10. It's like a pretty common example you'll see. If you go to an amusement park, this is probably something very similar to how they actually charge people at amusement parks. Probably a little bit more expensive, but similar idea. So, as you can see, this function that we're trying to write is going to return a number, how much we're going to be charged. And it's going to return 3 different numbers, depending on if it was after 5 p.m. or not, and depending on if the person was over age 10 or not. And so we have 3 different conditions here that we're going to have to check for. Is it before or after 5 p.m.? Is the person age 10 and up? And, well, the else, if they're under 10. And we're going to return 3 different values. Okay? So, well, the question stated formally, write a function admission that consumes 2 parameters, a Boolean value called after 5, which essentially just tells you, is it after 5 p.m. or not? And it consumes a positive integer age, and it produces the total associated cost. So like I said, it just tells you how much you're going to be charged to enter this museum. Question make sense to everyone? Okay. So how are we going to solve this? Well, the contract, first of all, is going to be admission is a function that consumes a Boolean, and it also consumes a nat. The after 5 is a Boolean. It's going to be either true or false. And the nat is going to be an age. It's going to tell you if the person is older or younger than 10. And we're going to produce a nat, which is going to be, well, how much we're going to pay to get into the museum. So our first condition is going to be checking if it's after 5 or not. And notice this is a question. Remember how I said in conditions we have question, answer, question, answer? This is a question. Why do we know it's a question? What is the return type of after 5? Boolean. And because the return type is a Boolean, we know this is a valid question. Because this is going to be either true or false. Right? Does that make sense to everyone? It doesn't always have to be like a string equals question mark or like a greater than function. It can just be a variable that takes in a value that's true or false. It has to be a Boolean value. Okay? So if after 5 is true, what are we going to return? Let's look at the question. It offers free admission for people who arrive after 5 p.m. So what are we going to return in this place? 0, right? Because after 5 p.m., we're not charging them anything. Else? Well, else, there's going to be a con, because now we have some other condition. We have to see if the person is over 10 or not. So if the person is younger than 10, if age is less than or equal to 10, then we return 5. Because we're charging them $5. And finally, if the age is greater than 10, then we return 10. Does that make sense to everyone? Any questions about that? And you'll notice here, we nested conditionals. We had a con, and then for one of our answers, the else, the answer for the else was another con. And we just added a bunch of question answers like before. Okay? Now, what we're trying to show with these slides is that anytime you have a nested conditional, well, you shouldn't really ever have nested conditionals. And the reason for that is because anytime you have a nested conditional, you can flatten it into one big expression, into one big conditional. So we're going to see how to do that. How do we turn this double conditional function into one big conditional function? Can anyone just think about how we do that? All we're really going to do is, where it says age is less than 10, we're just going to have that as our second question. And then, where age is greater than 10, that's just going to be our third question. Okay? So, same start. After 5, we return 0. And if it's not after 5, and if the age is less than 10, we return 5. So this is doing the same thing as the previous function. It's saying, if it's not after 5, and the age is less than 10, we return 5. It's doing the same thing. And then, same thing, it's the same, just the same, similar idea with the last statement. If it's not after 5, and the age is greater than 10, we return 10. Does that make sense? Good? Does conditionals make sense today? Put your hand up if conditionals make sense. Okay. Does conditionals not make sense? You're not listening. Okay. All right. I like the honesty. Okay. But listen. It's more important that you listen for this stuff. It's very critical for the rest of the course. Okay. Now, we can also write this function in one other way. If you look at after 5, it's a Boolean value. And so it's going to be either true or false. In our first condition, we check if it's going to be true. So in the second condition, where we do not after 5, we don't actually need to do that. The reason we don't need to do that is because we're never actually going to get to the second condition if the first one was false. Or sorry, if the first one was true. Only if the first one's false are we ever going to get to the second condition. And so what I'm trying to get at is this part that says not after 5 is not really required. And the reason it's not required is because if this is ever true, we're going to go here. And we're never going to come here. It's about short-circuiting. We're never going to come here if this is true. And therefore, this will never be false. It's impossible for this to be false. Does that make sense? The reason this can't be false is because, let's assume, how do we get this to be false? The only way this can be false is if this is true. But if after 5 is true, then we're going to go here. So we're never actually going to get to the statement. Well, sorry, the statement is never going to evaluate to false. And it's not going to, and the reason for that is because how do we get this statement to be false? The only way this statement can be false is if after 5 is true. Because not true will give us false. And if this is true, then this would be true. And if this is true, we would go here. So this is not required. Does that make sense? It's a little confusing, but it should make sense. Once again, if this is false, if this whole statement is true, this is false. Sorry. If this whole statement is false, this is true. And if this is true, we're going to go here. So, in the next statement, we can simply get rid of it. We simply just say, is age less than or equal to 10? And the reason we're doing this is we just assume that after 5 is false. Does that make sense? We can assume after 5 is false here. Because the only way we could ever get to this place in the first place is if after 5 was false. Only because after 5 is false can we get to the second condition. And that's why we don't even need to check in the first place if after 5 is true or not. Does that make sense? Good? The nods? Yeah? Okay, I'm seeing some of this, but I think we're good. Okay. And then else, return 10. And the reason else return 10, because now we know after 5 is false, and we also know age is bigger than 10. So both the conditions up there where we checked is after 5 true and is age greater than 10, both of those conditions are now not needed. And the reason both of them are not needed is because if ever in a question you check something and this is false, in the following conditions, you can assume that whatever you checked here was false. So when we checked age is less than 10, after we realized age was less than 10, in the next condition, you can assume age is greater than 10. Because if age was less than 10, we would return 5. We would return 5. Does that make sense? Yeah? The whole point is, if a condition evaluates to false, all the following conditions can assume that whatever happened here was indeed false. So when we got to the second condition and we checked age is less than 10, we already assumed after 5 was false. When we got to the third condition, we assumed after 5 was false, and we also assumed age was bigger than 10. Because we checked, if age was less than 10, we would return 5. So we know in the third condition, age has to be bigger than 10. And we also know it's after 5. Or it's before 5. Does that make sense? Alright, if it doesn't, go ask me after. Okay? So, what this is saying is a con can essentially be used like any other expression. So, if you have a number n, you can add a conditional statement to it. You can add n to, well, if n is even, add 1, else add 0. And notice, what are we doing here? We're adding the contract for plus takes into numbers. But this con statement, it'll definitely return us a number. Because the answer is a number. And so this plus statement is going to be adding n to either 0 or 1. Because the answers are either 0 or 1. So that's why this is allowed. It's allowed because all that con is doing is returning an answer. And in this case, the answers are either 0 or 1. And so we're going to be adding n to either 0 or 1. And that's fine. We can do n plus 0 or n plus 1. They're both fine operations. Okay? Good? Cool. Second one's pretty much the same example. I'm not going to go into it. Okay, third question. All right. Let's see if you guys are understanding this whole conditional business. Okay, so once again, the room frequency is AC. I haven't started it yet, so you probably can't do it right now. Give me 2 seconds. Okay, you should be able to register now. Okay, 1 minute left. Fifteen seconds. Ten seconds. Okay. Okay. All right. Moment of truth. This part always scares me because I don't know if you guys are paying attention or if I'm doing a good job, but let's see what you guys said. Oh boy. Oh boy. Yeah, you guys are all dumb. It's actually me. So, 14 of you guys are correct. Okay, so for everyone that voted A, I actually really want to know, why do you guys think it's A? Someone put their hand up. What value of Z would produce different answers for both of these? Yeah?
If Z is negative, then the first statement Z would be switched to positive, whereas the second statement Z would just stay negative.
If Z is less than 100. Oh wait, what the answer is wrong. Oh my god, no, you guys are right. I'm wrong here. Wait, hold on. Oh, why do you think it's C?
What implies something
If Z is negative, then we're inputting, you got a positive there, and you got negative. No, okay, you guys are right. No, I'm wrong. I'm definitely wrong here. Okay, no, in my defense, I'm not wrong. Let me show you who's wrong, because it's not me. I actually didn't bother figuring out what this was. So like, let me just show you guys what actually happened. So I have like answer slides here, and like in the answer slides, if you go to like, clicker question, what is it, clicker question 2? No, it's the next one. Oh, let me do that way. So like, all I did was, I looked at, oh, wait, where am I? Wait, we are here. Yeah, where? Yeah. Oh wait, no, it said no, wait, oh, I'm looking at the wrong, I don't know what's going on, I've had a bad day. Yeah, so apparently the answer is no. What was I looking at before? Oh, I don't know what I was looking at. Oh, okay. Anyways, okay. Big break for a second. It's alright, that happened. Long story short, answer is no. So for anyone that voted yes, why did you think yes? Because the reason it's no is because if you put a negative number, the first condition will result, on the left side, it'll result in a positive number, but on the left, or on the right side, or, okay. On your left side, it'll result in a positive number, but on your right side, it'll result in a negative number. And that's why they'll produce different values. Anyone want to say why they think B was the correct answer? Because, yeah, I would. Anyways, moving on. So A is the correct answer. And the reason is, if you input a negative number, left side produces a positive number, right side produces a negative number. Okay? Good? Yeah? Okay, awesome. Okay, next favorite question. Oh man. Okay.
Is that the same question?
Answer yes.
No, it's not the same question.
Answer yes. ये question दिखा था उसमें किसी yes वाला.
The title is the same for both the questions, but the questions are different. So I'll give you guys another 2 minutes to solve this.
बाकी तो कर लेंगे. मैं तो बात.
One more minute.
कोई करता है.
स्टेप बाय स्टेप
हाँ पता लग रहा है. हमारा
30 seconds. Ten seconds. Three, two, one. Okay. All right. Before I reveal the answer, if any of you guys are like a little clever and think a little hard, you should know what this is based on how I revealed the previous one, because I was looking at the answer for this bigger question and not for question 4. So if we go to the answer slide, what I was looking at was actually this, which says that the answer is indeed B. And so, yes, you guys all got that. And so yeah, that's what happened. That there was the brain part. I was looking at this slide, and so and they look pretty similar. The slides look very similar. So I was like, oh yeah, okay. So the answer is A, or the answer is B. But well, yeah. So anyways, okay. So how many people voted for the other one? If it's a small amount, I won't really go over. Or yeah, okay. So if you have any questions for why it's not B, just let me know. It's only when a lot of people vote for the wrong answer do I go over the reason. But it seems like you guys all understand this. Or you guys are all just really clever and know that I messed up and I looked at the wrong answer. Regardless, that's good either way. Okay. So yeah, it's just nested conditionals. It's just you're changing the way